Ever wondered how astronauts grow food in space? Well, it's a fascinating tale of human ingenuity and survival. It's a tale of lights, seeds, and zero gravity, a tale of overcoming the odds in an environment that's anything but hospitable. Space farming, or astroagriculture if you prefer, isn't just a hobby for bored astronauts. It's a necessity, a lifeline, the only way to sustain long-term space missions and potential habitation. Imagine being months away from Earth with no grocery stores in sight. You can't exactly pop out for a pint of milk or a loaf of bread, can you? Instead, astronauts have to get creative using cutting-edge technologies and innovative techniques to cultivate crops. They're not just growing food, they're growing hope, a future where humanity can thrive beyond the boundaries of our home planet. So let's delve into the history of space farming, a tale stretching from the first seeds to the first pizza. Space farming started as a mere concept, a dream that many believed was impossible. The idea of growing food in the cold, unyielding void of space seemed as fanciful as walking on the moon once did. Many skeptics questioned the feasibility of such an endeavor, citing the lack of soil, sunlight, and the unforgiving vacuum as insurmountable obstacles. But as history has shown us, when humanity is faced with a challenge, we find ingenious ways to overcome it. The journey towards astroagriculture began with a simple question: can seeds germinate and grow in space? To find out, scientists started sending seeds on their space voyage, tucked away in the cargo holds of spacecraft. These seeds, exposed to the harsh realities of space, would serve as the pioneers of astroagriculture. The significance of these first experiments was monumental. It was a step towards self-sustainability, a key factor in long-term space travel and colonization. But it was more than just about survival. It was about understanding how life, in its most basic form, could adapt and thrive in an environment so different from our own. The results were both surprising and encouraging. Many of these seeds not only germinated but also grew, albeit differently than their earth-bound counterparts. They proved that despite the harsh conditions, life could find a way. These initial experiments opened up a realm of possibilities. They showed us that the dream of space farming wasn't just a dream, but a tangible, achievable goal. If seeds could germinate and grow in space, then why not crops? Why not an entire garden or a farm? It was this line of thinking that paved the way for more complex experiments that would eventually lead to the cultivation of the first space-grown crops. It was a momentous achievement, a testament to human ingenuity, perseverance, and the undying spirit of exploration. These initial experiments laid the foundation for a new era of space exploration, an era where we wouldn't just visit other worlds, but grow, thrive, and potentially colonize them. The birth of astroagriculture marked the beginning of a journey that could one day see us become a multi-planetary species. Fast forward to 2015, astronauts munched on red romaine lettuce, a product of their own space garden. Imagine for a moment the sheer joy of tasting the first lettuce grown in space. Not just any lettuce, mind you, but red romaine lettuce, grown aboard the International Space Station, or ISS. This wasn't a simple gardening experiment. It was a testament to human ingenuity, a successful attempt to cultivate life in an environment where life, as we know it, doesn't naturally exist. The process of growing lettuce in space isn't quite like planting your typical earthbound garden. The lettuce seeds were embedded in a specially designed rooting pillow, filled with a clay and fertilizer mixture. This pillow provided the right conditions for the seeds to germinate and grow. But how do you water a plant in zero gravity, you might ask? Well, the answer is quite ingenious. The astronauts injected water into the pillow, and the clay mixture absorbed it, providing a moist environment for the seeds. And as for sunlight, well, there's plenty of that in space, but not in the traditional sense. The lettuce was grown under pink LED lights, which provided the optimal light spectrum for plant growth. This process took about 33 days from planting to harvest. And when the red romaine was finally ready, the astronauts didn't just dig in. The lettuce had to be cleaned with citric acid-based, food-safe sanitizing wipes before it was deemed safe to eat. The successful cultivation of lettuce on the ISS wasn't just about providing the astronauts with fresh food. It was about survival, resilience, and the potential for self-sufficiency in space. It was about paving the way for future long-duration missions, where resupplying from Earth might not be an option. This achievement wasn't just a win for space farming, but a win for humanity's ambitions of exploring and colonizing the final frontier. The lettuce grown on the International Space Station was more than just a salad ingredient. It was a symbol of hope for a future where humans can sustain life beyond our home planet. This success story marked a significant milestone in the history of space farming. But astronauts need more than salad, right? The quest for a more diverse space menu began. Indeed, we can't expect our interstellar travelers to survive on lettuce alone. Space agencies across the globe quickly realized the need for a broader range of crops, and thus the experimentation with different types of plants in space kicked off in earnest. Now, you might be wondering, what's next on the menu after lettuce? Well, the answer might surprise you. The next challenge was zinnias. Yes, you heard that right. Zinnias, a type of flowering plant. If you're scratching your head and asking why, don't worry, you're not alone. From a nutritional standpoint, zinnias don't carry much weight. They are not exactly a hearty meal, but they serve a different and equally important purpose. They are a morale booster. Imagine being 1,000,000 miles away from Earth, living in an environment devoid of nature's colors. The sight of a blooming zinnia could be a powerful emotional lift. But growing zinnias in space wasn't a walk in the park. The plants faced a host of challenges. Lack of gravity, for one, makes watering plants a tricky business. Astronauts had to carefully manage the moisture levels to prevent mold growth, a problem that nearly ruined the first batch of zinnias. But with persistence and some creative problem solving, the space gardeners were successful. In 2016, astronaut Scott Kelly proudly tweeted a picture of a blooming zinnia, the first flower ever grown in space. It was a moment of triumph, a testament to the indomitable human spirit. The successful cultivation of zinnias marked an important milestone in the journey of space farming. It showed that we could grow not just leafy greens, but also flowering plants in the harsh conditions of space. And the implications were far-reaching. If we could grow zinnias, what else could we grow? Could we one day have a full-fledged space farm, complete with a variety of crops? With these successes, the future of space farming looked promising. Pizza, a beloved comfort food, made its debut in space in 2017, marking a new era in space cuisine. Picture this, the year is 2017. Astronauts aboard the International Space Station, miles away from the nearest pizzeria, are craving a slice of the good old cheesy delight. That's when Paolo Nespoli, an Italian astronaut, casually mentioned his pizza craving during a live broadcast with ground control. And thus, the first pizza party in space was born. Making pizza in space, however, was not as straightforward as firing up the oven and tossing some dough. Microgravity presented unique challenges. For one, crumbs and toppings could float away, posing a potential hazard to the equipment and crew. Plus, traditional cooking methods were out of the question. But where there's a will, there's a way. The solution was a specially designed food kit sent from Earth. This kit included pre-packaged crusts, tomato sauce, cheese, and an array of toppings, all modified to be space-friendly. The astronauts assembled their pizzas using these ingredients, sticking them together to prevent any rogue pieces from causing chaos. The pizzas were then cooked using a food warmer, not an oven, but close enough for our pioneering pizza chefs. The event was more than just a culinary treat. It represented a leap forward in the quality of life for astronauts. The ability to prepare complex meals, not just for sustenance, but also for enjoyment, has tremendous psychological benefits. It's a small slice of home, a morale booster in an environment that is often challenging and isolating. This pizza experiment also opened doors for further culinary exploration in space. It demonstrated that with a bit of creative thinking and technological innovation, limitations of space travel could be overcome. It paved the way for more diverse and appetizing meals, making long-term space missions more feasible and comfortable. Pizza in space, a testament to human ingenuity and the evolution of space farming. With each small step in space cuisine, we're not just making astronauts' lives tastier, we're pushing the boundaries of what's possible in space. So what does the future hold for space farming? As we look ahead, we see a horizon filled with endless possibilities and a fair share of challenges. The aim is to create a sustainable food production system in space, capable of feeding a crew on long-duration missions, perhaps even on Mars. Emerging technologies like hydroponics and aeroponics could play a vital role in this endeavor. These soilless farming methods, which use nutrient-enriched water or mist respectively to grow plants, might be the answer to space's lack of arable land. Research is also being conducted on genetically engineered plants that could potentially survive harsh space conditions. Imagine, if you will, a tomato plant that could thrive in the Martian soil, or a strand of wheat that could grow in zero gravity. As we advance, the dream of self-sustaining space colonies inches closer to reality. Space farming, once a mere concept, now holds the key to our future among the stars.